Good morning, friends, and welcome back to the online learning platform at Department of Civil Engineering. Rajesh Gopinath, and we are back together for environmental studies. If you recollect, in the previous session, we had discussed about the significance of having a forest and what are the consequences with respect to deforestation. In today's presentation, we shall be discussing about advances in energy system, probably very relevant considering the fact that, we are in the times of COVID and your chief minister has recently agreed that all the tourist spot will be open because you have Dasara coming up. So probably if you look at this image on your screen, you can understand how much of energy or electricity is being consumed when any festivity happens. So friends, in today's presentation, I will introduce you to the new concepts of energy systems, the various types, briefly, what is the working principle, okay, what are the various applications, what is the advantage and disadvantage that follows with it. Finally, I shall be summarizing the same before listing the references for your kind perusal. Okay, now, what I want you to understand before we kickstart energy system is, when you talk about classifications, in your school days, you have learned something as conventional energy system, non-conventional energy system, renewable energy system, and non-renewable energy system. I'll give a small introduction to clarify if there are any discrepancies in understanding. First and foremost, any energy resource, any energy system that is profoundly or frequently being used, okay, that is something which is used in a day-to-day life, those are called as conventional systems. For example, our reliance on thermal power plants, that's a conventional system. Very few people rely on solar energy. It is not used in day-to-day life. That makes it a non-conventional system. So what you need to understand is those energy resources, those energy systems which are used day to day, which we depend heavily upon, they are conventional. And those that we do not depend heavily upon, we don't rely on them, okay, they are non-conventional. However, what we need to understand is slowly the bridge is decreasing. There are certain energy systems which belong to conventional, they may soon become non-conventional. Tomorrow, if you don't have any coal left, what thermal power plants would do? Okay, now let us say tomorrow we are able to develop an awesome technology to tap solar energy. Then solar energy will become conventional. No more it will be called as non-conventional energy system. With this understanding, let's look at the second classification. Energy systems are also classified as renewable and non-renewable. See, there is a small gap in understanding. People generally think that those energy resources which are continuously renewed are renewable resources, and in the same manner, those energy systems which cannot be renewed, they are non-renewable. I am very sorry, that is not the case. Both renewable energy system and non-renewable energy system, both of them actually are renewable in nature, but the rate at which they get renewed is different. For instance, solar energy is highly renewable. The rate at which solar energy reaches earth is imminent, but the rate at which coal is formed or crude oil is formed or petroleum is formed, it takes ages, it takes decades, it takes centuries, okay, therefore it is non-renewable. The idea is there is no way renewable resource can be exhausted because rate of replenishment is very fast. But if the rate at which we continue to exploit coal and petrol, okay, unfortunately it cannot be renewed or replenished immediately. So friends, I want you to have a clear understanding of conventional, non-conventional, non-renewable and renewable energy system. Let us start today's session with solar energy. Okay, it is a non-conventional system, it's a renewable system, but with the days to come, it may become conventional. What you need to understand is, when you look at your solar energy, basically we have only one sun. All right, and we know very well that the sun will be there for the next millions of years. Hence, there is a dependency and consistency that we can expect. But what we need to understand is, our Earth's surface, that is the surface of the Earth, it receives roughly around 10 to the power 14 kilowatt of solar energy from sun. But how much of that are we using? In fact, you will not believe it, that much amount of energy which is coming from sun is actually 5 times of what we require, or 5 times of what we consume. Okay. Yes, having said that, there are issues, there are gaps, but when you look at the screen, probably you might have come across this screen, which is mostly there across your houses. Okay, it's a solar heater. So basically, these panels that you're looking at, which is coming in various shapes, various sizes, they are called as solar collectors. Okay, these are the devices which are meant to entrap solar energy. And as ages proceed, they come in different shapes and sizes with technological evolution. Now, when it comes to your collectors, there are basically two types. One is your flat plate collector. Friends, that is the image on your top, okay, your left hand side and right hand side. That is a flat plate collector, basically conventional, you may rather put it across. Okay, however, there are new advances taking place and we have better forms, that is your parabolic or your concentrating collector. Now let me give you a brief glimpse of what they are. If you talk about your flat plate collector, which you might have seen in your rooftop or somebody's rooftop, basically the absorber plate is metallic. Okay, and they are usually coated black because black can absorb more heat energy. Whether you have tubes or channels or passages, okay, whatever it may be to integrate, okay, eventually they will be carrying water or any fluid. Let us say you're talking about a solar heater. Okay, finally, so what is that we have? We have a metallic absorber plate, we have a black coating. Okay, but at the end of it, behind it, or let us say beneath it, we have insulation. Okay, why do we have insulation at the back or at the sides? Simple. We want to minimize the heat losses. We want to tap as much as possible solar energy because, friends, we tap only 5% of solar energy what we receive. Remaining 95% is lost. And probably that is where an evolution has come, wherein we have parabolic or concentrating collectors. Again, if you look at these images, okay, they are also highly polished metallic surfaces. The only difference is they are in parabolic shape so that when the sun ray strikes the profile, okay, they get reflected to the focal point. In simple words, I can harness as much as possible solar energy. Okay, having said all this, please remember all your solar panels, you might have seen a transparent cover, a glass, and that is to permit radiation from the sun to enter the metallic plate. Let me show you a small video to make you understand how your typical conventional solar water heaters function. That is what you have on your rooftops. Have a glimpse of this video, which has been taken from YouTube. Actually, government is promoting solar energy now so that we can reduce our dependency on thermal power plants, so that problems such as global warming and climate change can be curbed. So friends, this is just a modification. Of course, different manufacturers have their own product, okay, but this is typically how your conventional solar water heater performs. So probably this slide and this video has given you a simple understanding of the two types of solar collectors. Firstly, the flat plate collector, which you might have seen across, okay, and secondly, the newly evolved parabolic collectors. But friends, solar energy also comes with merits and demerits. Okay, in simple words, you might say that, what do we do during cloudy days? What do we do during rainy days? And what will a country like Alaska do wherein it doesn't have sun for 350 days? Okay, yes, there are disadvantages and there are also advantages. Firstly, you're talking about a operation which does not involve any pollution. Okay, it's a renewable resource, and solar energy is something which has a wide range of application. Solar car, solar bikes, solar calculators, solar heaters, you name it, you have it. Okay, now the rate at which your power is generated, it's also economical. So these are the certain advantages that solar energy provides you. But there are certain disadvantages, such as, when it comes to a concept of storage. Okay, now when it comes to the losses, when you talk about the conversion of AC and DC. Okay, and yes, what do we do when there is no sun available? Okay, for instance, if there's a volcanic eruption, okay, with so much of sulfur sprayed over, your solar rays cannot strike the earth. So they are all locational disadvantages. But yes, since we do not have a great technology to tap solar energy, okay, we tend to spend more money with respect to the size of the panels. Obviously, we need more land, we need more areas, we need more number of solar panels. Okay, and definitely these are not going to perform during your seasons such as monsoon or your cloudy days. Okay, now having said all this, these are the reasons why your solar energy system become very costly for you. Even if you want to buy a solar system, the initial investment is very high, only because our technology is not foolproof. There are still gaps, okay? But there is one concept which many of us are not aware. Yes, there is no pollution connected with solar energy during operation, but all these solar cells that you're talking about, you might have studied in your electronics or your physics, NPN, semiconductors. Okay, they basically employ cadmium, okay, which is a heavy metal, and definitely we are talking about industrial wastewater pollution. All right, now with respect to advantages and disadvantages, there's a small thing I want to add on. Opportunities. Friends, you are computer science engineers, there's an opportunity that you can tap. Please remember, I always said artificial intelligence will perform well provided natural intelligence is in place. Okay, now if in case our technology has failed, it's only because our natural intelligence has not worked. Let me show you a small video wherein AI has introduced the natural intelligence into it. Let's look at this video, and you might find opportunities for yourself to enter into these domains. They call it smart flower, but let me tell you, they got this idea from sunflower. I'll show this video once again to you. Please remember, even when you talk about solar energy, the basic idea is that we have copied the concept of photosynthesis. You know very well that the green plants have the potential to convert carbon dioxide to oxygen. Okay, they do it during the presence of sun. During the night time, they indulge in respiration. But unfortunately, though we have understood photosynthesis, we have not been able to tap the complete potential, or utilize the knowledge with respect to mitochondria or ATP. So what I want you to re-stress here is, when you look at this video, they have copied the concept from a sunflower. Everyone knows that, the way it has been named, the flower blooms, okay, when in the direction of sun. But that's not the end of it, my friends. Sunflower, okay, when it blooms best, that depends on the temperature, which invariably depends on the intensity of solar radiation. So let's look at this video once again. So that, my friends, was a very simple concept wherein we have, undertaken biomimicry, wherein we have mimicked the nature, and that comes from observation, that does not come from looking at nature. Okay, now let's move on to the next advanced technology in terms of energy systems, and that's OTEC, Ocean Thermal Energy Conversion. I do not know how many of you have the habit of reading books, or when you were kids, during your school times, if in case you have gone to your library and if you come across a book like this, 20,000 Leagues Under the Sea, if you have read it, then probably, you will be able to connect the technology that I'm talking about, because that in year 1870, okay, that book spoke about a technology which actually, was again conceptualized 11 years later by a French physicist. Okay, but from 1870 until the next 5 decades, the concept of OTEC never came into the picture. It is only in the 1920s that ocean thermal energy conversion actually came into system, actually came into practice. But it was due to the efforts of this gentleman, Jules Verne, who fantasized it, and this gentleman, Jacques, who conceptualized it. Okay, in simple words, my friends, if I have to tell you about OTEC, it's a technology wherein we understand the basic fact that your ocean, your sea, okay, they are huge structures, they are huge water bodies which are very deep. And we have a common knowledge that, when the sunlight strikes, okay, the sunlight penetrates the water, but the sunlight cannot penetrate the entire depth of a sea or the ocean. So obviously what is going to happen, okay, whichever part of the oceanic depth or the sea depth the sunlight comes in contact, the water there will be warm. But as you go deeper and deeper, the water will be cold, ice cold. Okay, now hence it is obvious that there is a thermal stratification. It is obvious that there is a gradient wherein there is a temperature difference as we move from the top layer to the bottom layer. Okay, and this temperature difference, my friend, is very huge. Okay, and if the temperature difference can be more than 20 degrees Celsius, I can utilize this. But at the same time, if this temperature difference is not so much, then it becomes very difficult for me to extract this energy. The concept of OTEC, though it has been practiced in US and Japan, it has not been very successful. Okay, and one of the major reason is because you cannot go about installing these plans wherever you like. Okay, you need the temperature difference, and friends, these conditions of thermal stratification, they exist in the tropical coastal areas, that is roughly between the Tropic of Capricorn and the Tropic of Cancer. Okay, hence if you're able to identify the proper locations and install them, then probably your energy extraction becomes easier. Otherwise your energy extraction becomes extremely difficult. Now when it comes to your ocean thermal energy conversion, okay, we have three systems: closed cycle, open cycle, and hybrid cycle. Okay, I'll explain these systems one by one to you. Before I continue further, just have a look at the video. So basically, these are the parts of your OTEC. There will be a turbine, there will be a generator, there will be a pump, there will be an evaporator, there will be a condenser. Friends, it is as simple as your tidal energy. In case if you're aware about how electricity is generated by storing the water on your dams, okay, wherein the water is released from a considerable height, and that water through the penstock, it rotates turbines, and this turbine is of course connected to a shaft. This shaft is connected to a generator, okay, which obviously produces electricity. So I need a mechanism to rotate the turbine. If in case your tidal energy depended on the water which is stored in the dam to rotate the turbine, I still need one more information. I need one more utility. I need one more aspect which can rotate the turbines in your OTEC. And here we basically use fumes. Here we use vapor. Have a look at the video. Let's continue. So you might have come across the word, ammonia. So I'll play the video once again for you. So I have a system, I've got pipelines, I have a depth, okay, and what I understand is the water at the top surface and the water at the bottom surface have drastic temperature differences, which I'm going to capitalize. Yeah, so let's continue further. Now let me explain to you the different technologies. Okay, so first is your open cycle. Friends, this open cycle is also called as Claude cycle, okay, CLAUDE, based on the person who invented this. Now what you need to understand is in this open cycle, basically, okay, what is that which is going to rotate the turbine? Remember, it is going to be water vapor. The working fluid in an open cycle, that is the fluid, okay, which is going to indulge in the transformation, resulting in a fume which rotates a turbine. That is the warm surface water itself. In simple words, if I bring the cold water and the warm water, which has a difference of more than 20 degrees Celsius, if I can bring them in contact with each other, please remember, not the physical contact, rather they will be in a contact with the materials. For instance, let us say I have a pipeline which carries the the cold water, and then I have the I have the warmer water around these pipes. Due to the temperature difference, the warm water gets converted to water vapor, and this water vapor, okay, it starts rotating the turbine. This turbine is connected to a shaft, and then this shaft is connected to a generator, wherein it results in electricity. But what happens next? Let's recap. First, I pump the water from the great depths, that is the cold water. Okay, then I bring a system in such a manner that the surface water, which is warm, and the cold water at the bottom, I bring them in contact with each other, not physically, okay, not directly. When the contact happens, the water evaporates. This water evaporates and becomes water vapor. This water vapor enters the turbo generator unit, wherein it rotates the turbine, which is subsequently connected to a generator. After that, this water vapor enters a condenser, wherein the water vapor gets condensed into fresh water itself. After this, this fresh water is released back into the sea or the ocean. Now listen very carefully. Why do I call it open cycle? Because in the condenser, the water vapor gets converted to fresh water, and this fresh water is dumped back into the ocean. So it is open cycle. Friends, there is one disadvantage of the system. Remember, your ocean or your sea is a saline ecosystem. It contains sodium chloride. When you dump more and more fresh water which does not contain sodium chloride, you are playing with a potential ecological catastrophe. Obviously, the fishes, okay, the aquatic species which survive in a saline ecosystem cannot survive in a fresh water. You are imbalancing the salinity gradient, and this is going to have a consequence with respect to the climate of the earth itself. Anyways, this is your open cycle. Then what will be a closed cycle? Obviously, when it comes to a closed cycle, see, the understanding is same. I will have a working fluid, okay, which will get converted to a fume. That fume will rotate the turbine, subsequently generator, electricity is produced. But why we call it a closed cycle is because in this technology, the working fluid fumes, when it comes to a condenser, it gets converted to a liquid, but this liquid is not dumped back into the ocean. The reason is because here the working fluid is a chemical. Typically we use ammonia, okay. Please remember, let us say, you go to a chemistry lab or an environmental lab, and if you end up opening ammonia bottle, ammonia vaporizes so fast that a person who's standing in the other corner of the room will also feel that this ammonia is getting released. Okay, so the vaporization ability. So friends, the technology is same, the concept is same. The only difference is the working fluid is ammonia, and after condensation, this ammonia is recycled. It is not dumped back into the ocean because ammonia is toxic, ammonia is poisonous. Now, I have covered more or less the advantages and disadvantages, but yes, it's a renewable resource, it's a natural resource, and subsequently what is happening, you're not depending on coal. But yes, as I told you, disadvantages is with respect to the cost, because the technology is not well developed, and it is a localized disadvantage. You cannot go about having the system everywhere, just like geothermal energy. Eventually, my friends, the efficiency is very poor and extremely expensive. Now, with this basic understanding of your OTEC, Now, let us move to something simpler, which we are aware of. Wind energy. Okay. Now, we know very well that Earth has different surfaces, land, ice, water, and of course, your greenery. And all of these surfaces have different potential of absorbing the heat and releasing the heat. Okay. And as a result of this, the air which is near the surface, or rather the ambient air which is near these surfaces, they get differentially heated up, they get differentially cooled. As a result of this, you have warm air and cool air, and you know very well that the warm air tends to rise and the cold air tends to settle. Now this is the no as a result, the outcome of this is what we call as a breeze or a wind. Okay, so this is a simple logic that wind is actually being generated naturally on the earth. It is renewable, it is not exhaustible, so why don't we tap this energy? So to understand the concept of wind energy, let's first understand the concept of how your fan runs in your house, in your room. What do? You go and switch on a button, okay, on the switchboard, okay, electrical energy. When you do that, the fan rotates, mechanical energy. Wind is produced, wind energy. So in your house, what happens is electrical energy is converted to mechanical energy is converted to wind energy. The reciprocal of this, the opposite of this happens in your wind energy. Okay, let's look at this animation. There is wind which is blowing, the wind rotates the turbine. So wind energy is converted to mechanical energy. This turbine is connected to a generator, okay, which produces electricity. So in wind energy, what happens? Wind energy converted to mechanical, and mechanical energy converted to electrical energy. So this is a simple working principle and operation of a windmill or a wind turbine. Now, see, the various modifications will be with respect to how do these turbines rotate. Okay, are they rotating about the vertical axis or are they rotating about the horizontal axis? So these are the two modifications for wind energy. Now, what are the advantages? Yes, does not produce pollution. You can install them in locations which are very remote, probably on the outskirts, on the mountains, wherever there is potentially very good wind generated, there you can go about doing it. And you don't need transmission lines, so you're saving a lot of money. But what is the disadvantage of wind energy? Again, the technology is not so well developed, hence the investment cost is very high. Okay, you require large amount of area, and the maintenance cost is even higher in case of monsoon or frost. Okay, and yes, apart from this, there is an ecological threat for the birds. I'm not talking about the native birds, I'm talking about the migratory birds. These are those birds which come from different continents, and when they come following the natural trail, okay, they're much smarter than us, they have the natural GPS based on the sun. But when they come, and when they don't realize that a new structure has come up in its path, they eventually get killed, they get culled. Okay, friends, I'm sure you must have seen these wind turbines. Now if you go towards Chitradurga, okay, if you go towards Salem, if you go towards Anantapur, you will find a series of these wind turbines installed. Okay, now let's move to one more technology, which is your tidal energy. All of us know that there are tides which are generated naturally, which is due to the combination of the gravitational forces of the moon and the sun. We also know that they are produced twice a day. We have high tides and we have low tides. Why don't I tap this potential? How can I do it? Okay, now let me show you a video before I proceed further.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines.
Yes, you cannot have tidal plants, within the continent. Obviously, wherever there is a coastal line, shoreline, only there you can have tidal plants.
Coastlines often experience too high tides and too low tides on a daily basis.
Friends, you need to observe very carefully low tide, high tide. Obviously, when you have so much of water standing, it means there's a greater potential head. Okay, just try to simulate this condition with a dam. more the water stored in the reservoir, okay, greater will be the potential head, greater will be the force with which the water falls down, rotating the turbines.
The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbine.
Friends, there are two basic systems in which you can produce tidal energy: offshore, onshore. Okay, now onshore is wherein you have most of the construction aspects along the beach. Offshore is wherein you have the entire system within the water body itself. Probably, if you've seen the movie Finding Nemo, okay, you would have seen tidal technologies. Now let me tell you, what you see here, tidal fences, this is offshore, entirely inside the water. Okay, tidal turbines, this is also offshore, entirely and enter the water. Okay, but this tidal barrages, this is onshore.
Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity.
Now, I want to, play the small part of it once again.
Electricity. Tidal compresses air.
See, what is it we need to understand? We are trying to, simulate the conditions of a dam on a smaller scale. Now, just try to imagine, okay, this is a portion of your shore. This is a portion of your beach, okay? And let's say we have a depression created here, and this is the area of your sea. What happens whenever there's a high tide or a low tide? Okay, whenever there's a water coming, the water will tend to come when the high tide happens with the difference of 5 meters head. When the water is coming from the sea, the water comes here, rotates the turbine and falls into the system. Okay, so due to this potential head, the turbine rotates with a sufficient velocity, which is of course generating electricity. Over a period of time, the water comes, rotates the turbine and gets collected. At what point of time there is so much water which is collected on the shore, which can be re-released, and this water again returns like this into the sea, okay, by rotating the turbine and generating electricity. As simple as that.
Which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management.
So friends, this is your offshore structure, because you have the entire system inside the water. But yes, again, there should be transmission lines connected to tap the energy and transmit it.
This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far, the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity, and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
So friends, I hope you have a good understanding of what is tidal energy. Okay, now let's try to have a small recap. So now if you're looking at your structures, your onshore structures, when the tide is coming in, okay, the water gushes in from here, rotates these blades, okay, and enters this depression. Okay, again electricity is produced because turbine is connected to shaft to a generator. Now over a period of time, sufficient water is collected here, and when it is released, when the gates are opened, the water again gushes out into the sea, again releasing or producing electricity. Okay, now friends, this is again a simple representation of your entirely offshore structure. The entire structure is inside the water, and this is your onshore structure. Okay, let's move further. Now, what are the advantages? Yes, it's a renewable resource, inexhaustible. There's no pollution cost. Yeah, you do have a great higher output when compared to wind energy, but there are certain disadvantages again. And the disadvantage again comes in with respect to infrastructure, the operation and maintenance. It comes with the capital cost, installation cost. Okay, and please remember, whenever you talk about onshore structure, you need a great potential head. Obviously, with a low head, you can't generate electricity. You cannot have a variable output. You need to have a steady output. Only when you have a steady output, the electricity is dependable. The energy system is dependable. Apart from this, yes, it can also harm the aquatic life because they are blades. Okay, they can cut the aquatic species. And yes, since they are talking about equipments which might require lubrication, you might have leakages of oil and grease as well. So friends, this is an understanding of tidal energy. Now let's come to something more recent, and that is your hydrogen energy. Or rather, probably in your school days, you might have studied something about fuel cells. Okay, so you know very well that when you talk about energy systems, so far we have studied about mechanical energy, but here we are talking about chemical energy. We are utilizing chemical reactions to generate electricity. So any system for that matter, in your chemistry days, you must have remember, okay, you will have two electrodes. One is a cathode, okay, one is the anode. Cathode has positive charge, anode has a negative charge, and the solution that you're looking at here is an electrolyte. So when I can develop a chemical reaction to produce electricity. Okay, so before I continue further with this new technology, let's look at this small video. So friends, basically you're going to look at a fuel cell. Please remember, fuel cell is a device which produces electricity. Okay, and it does it chemically by combining hydrogen fuel with oxygen from the air. And you know very well that when hydrogen and oxygen are combined, the output would be water. Now, when it comes to a source of hydrogen, okay, the sources can be plenty. For instance, even your alcohol can be a source because it contains abundance of hydrogen. So friends, what you see, you basically see that hydrogen and oxygen have combined to form water. Friends, this is basically the opposite of electrolytic process. Electrolytic process is that process wherein, water can be separated into oxygen and hydrogen. That is electrolysis. So the opposite of electrolysis is what you see here. So fuel cell actually works in reverse of a electrolysis process. Okay, now see, when it comes to its applications, there's much yet to be explored. Okay, yes, this is a new technology, and inadvertently, not most countries would go for it, but yes, we do have buses which run from your hydrogen energy. Okay, now what we need to understand is there's one major disadvantage when it comes to your hydrogen as a source of energy, and that is because if you try to compress hydrogen more than a specific point, it will explode. So what happens? Storage is becoming a concern. So if you want a greater power, you need more fuel, but in this case, if you want more fuel, you need more storage space. So that is one of the major drawbacks or concerns of hydrogen energy. So friends, we're almost done with the presentation, and just to brush your basics, you all know that hydel energy is wherein we tap the energy from the water stored in dams. And yes, of course, nuclear energy is of course a controversial form, wherein we do not know whether to call it conventional, non-conventional, renewable or non-renewable. Okay, because when it comes to nuclear, you just need a very small amount of nuclear material, radioactive material, to produce electricity. But yes, of course, the controversies follow with a lot of disadvantages. Okay.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine.
So it is moving water here. So even in your tidal energy, it was moving water. In your OTEC, it was fumes or water vapor.
This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins.
In your wind energy, this was moving air, wind.
There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow.
Please remember, we do have a misconception that the water that we see falling from the dam, okay, that's your spillway. That is not the water which is generating electricity. If you observe carefully, there'll be a huge pipe which is, coming from the crest to the bottom, the penstock. The water which is falling into that penstock is the one which is, connected to a turbine.
The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
So that friend was a concept beyond your VTU curriculum for you, just to recap your basics. And yes, now when you come towards certain other unconventional resources, we do also have biogas energy, wherein we tend to utilize the energy wherein it comes as a product of decomposition of any organic matter. Okay, it could be the cow dung, okay, it could be your vegetables waste, peels, it could be your plants. Okay, and of course there's one more technology, which is geothermal energy. We'll have another 1 minute look at that.
Geothermal. Geothermal refers to producing energy from the internal heat of the Earth. The internal heat of the Earth is generated from radioactive decay of minerals and continual heat loss from the Earth's original formation. Geothermal wells are drilled into the Earth's crust at approximately a depth of 3 to 10 kilometers. The heat is extracted with a variety of methods, but in most cases is drawn from the Earth using water and steam. Hot water from the Earth may be directly extracted to heat homes and buildings. This is done either by directly circulating the hot water through buildings or by pumping it through a heat exchanger that transfers the heat to the building. Geothermal heat can also be used to produce electricity in a geothermal power plant. Electricity is generated when geothermal heat produces steam that turns turbines on a generator.
So here again, it is a steam or water vapor or a fume which is rotating the turbine. So basically the logic is same. Whatever form of energy you're talking about, it eventually comes back to a working fluid or some mechanism which is going to rotate a turbine connected to a generator via a shaft. The same logic applies for nuclear energy as well. Okay. However, when it comes to biogas energy, we are talking about a mixture of gases, majorly composing of carbon dioxide and mostly methane.
The major regions of geothermal development are in the most volcanically and tectonically active regions of the world.
If you can have geothermal energy within the continent, you can have your ocean thermal energy currents, conversions, you can have your tidal energy only where the water is available.
Though geothermal energy is currently a small player in the world's energy mix, one of its key advantages is its reliability and consistent power generation, which means it can provide baseload electricity. Concerns with geothermal include the accidental release of CO2 and hydrogen sulfide emissions stored in the Earth's groundwater that is often used to carry geothermal heat to the Earth's surface. Additionally, drawing heat from the Earth's crust can, if done irresponsibly, lower the ground temperature below the surface. The upfront costs for geothermal energy production are relatively high. It is expensive to carry out the seismic sensing, test well drilling, confirmation testing, and other necessary preliminary investigations to ensure that your new geothermal plant will be capable of meeting desired production. That's geothermal.
So friends, the idea of showing you these videos is to make you realize that there are technologies beyond what we have studied. There are technologies which are beyond the university curriculum. And now what we need to understand is, despite all this hue and cry, we still depend on thermal power plants. Our dependency on these renewable resources are so less. So there's a scope, a lot of scope of work to be done in developing these systems so that the earth can be a safer place. But yes, there are always merits and demerits for every system. So friends, what did we learn today? We understood the classification of energy systems, the various types, and the corresponding merits and demerits. So these are the references which I've gone through, all right? And you can always go through any other materials for add-on learning. And in the next class, my friends, we'll be learning about carbon trading. Again, a new concept in this context. So friends, I thank you all for your kind patience and hearing. Now this session is open for any queries and any questions that you might have. Thank you.